Hi guys, I'm Miss Edwards. This is your lesson 1-5, solving equations using square roots and cube roots. Before we begin, let's go ahead and review some of the things we talked about last time. A cube has a volume of 125 cubic inches. What is the length of each edge? So when you see cube and cubic inches, that tells me that I need to take the cube root of 125. So the cube root of 125 means what times what times what equals 125. So which number should go in the blank? Yeah, you're right. It is 5 times 5 times 5. 5 times 5 is 25. 25 times 5 gives us 125. So the correct answer is the length of each edge is 5 inches. Okay. Sonia wants to sew ribbon along each side of a square pillow. If the pillow has an area of 144 square inches, how much ribbon will she need for each side? So we see square and square, so that means we're going to use the square root of 144. Okay, that means what times itself equals 144? Yeah, 12 times 12 equals 144. You can use your calculator or you can think about it. So again, our unit is inches, so our answer is 12 inches. All right, number 3 has a two-parter, okay? The volume of a box of earring is 216 cubic centimeters. What is the length of one edge of the box? So we can do that the same way we did before. So it says cubic inches, so we want the cube root of 216. And I'm going to remind you guys how to use your calculator for this one. So if we go to our Desmos calculator and we hit the n square root button, we're going to tell it we want the cube root and we want to take the cube root of 216 and we get 6. Okay, so it's just a refresher which buttons you need to hit. So each length of the box would be 6 and our unit is centimeters. Now the second question says, what is the area of one face of the box? Well, if we think of one face of the box, it is a square shape, okay? And if it's 6 centimeters wide and 6 centimeters tall, what would the area of the inside be? So we have to do 6 times 6 to find what's in the inside. So the area would be 36 centimeters, and area is always squared. Volume is always cubed. Okay, so you see one was a volume problem involving cubes, and the other two, this one was square involving area, and then this one kind of did both. All right, so like I said, today's topic is solving equations using square roots and cube roots. It's very similar to our last lesson. We are going to use these to talk about real world contexts, so real world problems when you would use these. Before we begin, I want to think about a perfect square. So we talked about the perfect square is a product of a rational number multiplied by itself. Okay, so something times itself equals 25. What number do you think should go in that space? Okay, so many of you are probably thinking 5 times 5, and you are correct. Is there any other numbers that would also work? Remember, the number has to be the same in both spaces. There actually is a number that would work. It is -5 times -5. Why does that work? Well, a negative times a negative equals a positive. So if you notice, perfect squares actually have two different answers. So if I said the square root of 25, okay, one possible answer is 5, or it could also be -5. So square roots have two possible solutions. All right, let's think about perfect cubes. Could they have more than one solution? All right, so we want to figure out the cube root of 125. Okay, so what times itself 3 times goes 125? Again, 5 times 5 times 5. Okay, so one possible solution to the cube root of 125 is 5. Now let's see if the negatives work. Excuse me. If I do -5 times -5 times -5, am I going to get 125? Well, -5 times -5, that gives me positive 25. What's positive 25 times -5? Well, positive times negative actually gives me a negative 125. So this one is not the same. You cannot have a negative when it comes to the square roots. Cube roots. So square roots can have 2 possible answers. Cube roots will only have 1 answer, okay, because the negatives do not work. All right. So this is a real life example. Darius is restoring a square tabletop. He wants to finish the outside edge with a piece of decorative molding. What total length of molding will Darius need? Okay, so this was a figure that we've seen before. They have the picture here of the table. They drew the figure. The area of the inside is 125. We do not know what the 2 sides are. Okay, so this formula I showed you in the last lesson, area equals the side squared. Because remember, to find the area of a square, we do side times side, which is the same thing as side squared. So we're going to fill in any information we know. In this situation, the only thing we know is the area is 25. So I'm going to put 25 in where A is, but I'm going to keep S squared alone. All right. Can you remember what the inverse of squaring something is? How can I get rid of this 2? If you think square root, you are correct. The square root will cancel out the square. They go away. So S will be by itself. And whatever I do to this side, I have to make sure I do the same thing to the other side. And the square root of 25 is 5. So that means that each side of his table would have to be 5 feet. So 5 feet by 5 feet. Okay. So I just use an equation to solve for the missing sides. Let's see if you can try this one. Same concept. This time, our area is 100 meters squared. Go ahead and pause this video and see if you can figure out what is the length of each one of these 2 sides. All right, so if you took 100 and you substituted it in for A, you are correct. Okay. We can see in the next step, they did it for us. If they take the square root of this side, that means you also have to take the square root of 100. All right, so what times itself? We're thinking what times what equals 100. Okay, 10 times 10 gives us 100. So 10 would be our answer. Now notice how they have this symbol right here. That is very important because remember we talked about how squares have 2 answers, 2 square roots. So it could be positive 10 or it could be negative 10. So technically has 2 answers. So they put this plus or minus is how we say it, plus or minus 10, okay? Now here's what we have to think about. If this was a table, would it make sense to have negative 10? Could a table have a length of negative 10? No, it cannot. So for this one, we know it's plus or minus 10. But down here it says, why are there 2 possible solutions to the equation? Explain why only one of the solutions is valid. So in this case, in this situation, this is why we have 2 solutions, right? And why is it only one valid? You can't have negative lengths. There may be other cases in math where a negative number would be appropriate, but in this case, if I was a carpenter and I was making a table or measuring something, whatever I'm measuring would not have a negative value. All right, solving this one. So this time I see this is a terrarium or a tank for this iguana. Kyle has a large cube-shaped terrarium for his iguana. He wants to cover the opening with a square screen. What are the dimensions for this screen? So we see the square screen here, and we see the volume of the entire box. Okay, so this is the formula for volume of a cube. So it's side times 3, and that's, or sorry, side cubed, which is side times side times side. So you got to think, it has a width of S, it has a height of S, but it also has this depth of S. And that's why we have to do our length times width times height for when we talk about volume of cubes. Okay, so this is the formula. We know V is 343. And we know S cubed because we're not sure what S stands for yet. So we have to undo cubing something because I want S all by itself. So to undo a cube root, what do? You're right, we cube root it. So I'm going to take the cube roots of this side, and I have to take the cube roots of this side. Whatever you do to one side, you have to be fair and do the same thing to the other. Okay, so the cube and cube root are going to cancel each other out. So we have S equals, and let's use our Desmos calculator to figure out what the cube root of 343 is. So I'm going to get my Desmos calculator, clear it. I'm going to use n square root. I want the third root or cube root of 343. And you see my answer is 7. So the side lengths are 7. Okay, so it says, what are the dimensions for the screen? The screen would be 7, and our unit is feet by 7 feet. Okay. All right, see if you guys could try this bottom one. Go ahead and pause your video. All right, this one's just a regular equation. I see x cubed, so to undo the cube roots, I'm just going to rewrite this here, x cubed equals 64. The opposite of cubing something is to take the cube root. The opposite of squaring is square root, the opposite of cubing is cube root. The 3's are going to cancel each other out, so we have x equals, and then the cube root of 64. So what times itself 3 times gives you 64? If you're not sure, again, grab your Desmos calculator. N square root, we want the third root of 64, and our answer is 4. Okay, so x equals 4. Pretty easy. All right. So let's talk about these real quick. How would I solve for x in this case? If you said I need to square root both sides, you are correct. So you're going to square root both sides. Our square and our square root cancel out. So what is the square root of 50? Ooh, so some of you may be figuring out that 50 is not a perfect square. If I type that in my calculator, and it's a square root, so I'm going to use the regular square root of 50, I get a decimal. So that tells me 50 is not a perfect square. So what we are going to do is we are going to leave it as the square root of 50, but how many solutions do square roots have? Square roots have 2. So if you notice, they give us this. They say plus or minus the square root of 50. Okay, they put that little symbol there because there are 2 solutions. It could be positive square root of 50, or it could be negative square root of 50. So if it is not a perfect square, leave it as a square root, leave it as a radical, but just make sure that all square roots have that plus or minus because it has 2 solutions. All right, when it comes to cube rooting, how do I undo cubing something? I need to cube root both sides. And then if I were to type in the cube root of 37 in my calculator, I get the same thing. I get another decimal. It is not a perfect cube. So I'm going to leave it like the cube root of 37. How many solutions do cubes have? Well, cubes only have 1 solution. So that one you're just going to leave as the cube root of 37 because it has 1 solution. Okay. All right. Go ahead and pause your video, and I would like you to try these 2 down the bottom. Okay. So let me scroll down a little bit. If we take the cube root of both sides, so I say the cube root of a cubed oops, equals the cube root of 11. So I know my cubes are going to cancel each other out, my cube and cube root, and I get A. This is not a perfect cube, so I'm going to leave it just how it is. So that is my answer. All right, over here I have C squared. I need to take the square root of both sides. Okay, so the 2 and the imaginary 2 here are going to cancel each other out. So we have C equals. Now be careful, cube roots have 1, square roots have 2 answers. It could be positive, plus, or minus the square root of 27. So that means it could be positive square root of 27 or negative square root of 27. You have to have either the plus or minus, or you have to write them out. Whenever you have squares, there are 2 solutions. Okay. All right. So we already talked about this. Make sure that you have your 2 solutions for square roots, 1 solution for your cube roots. All right. If you need additional practice, there is some practice here on page 35 in your textbook. I will also link this on Schoology, so if you don't have your workbook with you, you can always use this, but these are some good extra examples. And your task for today is to complete the exit ticket that's on Schoology. It is exit ticket 1.5. It's in today's folder. If you have any questions, please send me a message.